Hey guys, in this video we're going to be talking about reading two-way frequency tables. So first of all, a frequency table is basically where we say, okay, I surveyed a group of people and I have certain criteria that I surveyed them about. In this case, two different criteria, thus the two-way frequency table. And then this tells me how often these two things happened, how often these two things happened, and so on. So basically, I could look at this and say, okay, 78 people were both between 18 and 22 and used Facebook. 70 people were over 23 and used Facebook. 4 people were between 18 and 22 and didn't use Facebook. And 67 people were over 23 and didn't use Facebook. So these numbers correspond to two pieces of information. From this, I can figure out a lot of things. I can figure out how many 18 to 22-year-olds were surveyed. I just add these numbers together. So that would be 78 plus 4, or 82. So 82 18 to 22-year-olds were surveyed. I could do the same thing for people that were over 23. I could say, okay, how many of those people were surveyed? So 137 of them were surveyed. Notice that these two things are mutually exclusive. You can't be in both of these groups, and you can't be in both of these groups. So I know that these numbers are true because I know that there isn't like somebody who's somehow in both of these groups. You either use Facebook or you don't. You can't put yes to both of those things. You're either between 18 and 22 or you're 23 and above. You can't be both of those ages, right? You could be younger than 18. So there could be a third group of people. This was a college survey, so that would be a very rare group of people. But you could have that third group, but you can't have someone who's in both of these, is the point. All right, so continuing on, I can figure out how many people surveyed used Facebook by adding these two. So I get 148 for that. 148 people use Facebook, and 71 people don't. And then I could add these together, and I could add these together, and I could get the total of the whole thing. So these added together should be the same number. So 82 plus 137 is 219. 148 plus 71 is also 219. So that's good. So this is the complete total. That's the number of people who were surveyed total. Okay, so now that we've done all of this and we've looked at what we can do with a frequency table, we can do other things, but for the sake of this question, these are some things we can do with a frequency table. Let's look at what they're actually asking for. So they're saying how many students in the survey were in the age category of 18 to 22. So regardless of using Facebook or not using Facebook, who's in this category? So let's look, we can just add these two together. We've already done that. That was 82. So 82 people in this category. So this row corresponds with 18 to 22. So the answer is 82. So that's really all they're asking for here, is we just add these two numbers. So you can have more rows and columns. It doesn't really matter as long as you just have two types of categories. So like in the last one, we could have had that third age group and it still would have been a two-way frequency table. So this one is income versus which university they go to. So how many graduates came from University A? So we're looking for everybody in University A. So that would be adding all of these together. So 35 plus 90 plus 35. Well, 35 plus 35 is 70. 70 plus 90 is 160. So that would be the answer there. And that's pretty much it. So we're just looking and adding things up like that. All right, so let's look at the next one, which is to create a two-way frequency table. So in this, you're given some information and they've set up the table for you, so you don't have to do that, but you're going to use this information to make the frequency table. So the data was collected on whether 65 professional golfers have practiced for at least 10,000 hours in their career and whether they have won a major championship. The Venn diagram below shows the data. So there were 65 professional golfers surveyed. So that's the total. We're given that. And then here we were told, 14 practiced 10,000 hours but didn't win a major championship. 37 did both, right? Practiced 10,000 hours and won a major championship, and 8 won a major championship without practicing 10,000 hours, and 6 have done neither of those things. So we can use this information to make our table. So we want ones that have won a major championship and practiced for at least 10,000 hours. That's this first one, right? Both of these things. That's this spot right here, right? Both of those things. So 37. Have not won a major championship, but have practiced 10,000 hours. That would be this one, right? Not in the red circle, but is in the blue circle. So that's 14. Have not practiced for at least 10,000 hours and did win a major championship would be the 8. But if they haven't done either, that's this 6 here, not doing either of those things. And if you add those all up, that should give us our 65, but I'm not going to check because we don't need to. All right. So this one, we're not given a Venn diagram, we're just given some information. So Lena knows the following information about the box of 18 candles. So we know the total is 18. 10 candles contain both chocolate and caramel. So our options are contain caramel and not contain caramel, contain chocolate and not contain chocolate. Those are the things we're comparing. So 10 contain both. So contain both would be this box. 3 contain neither. Contain neither is this box. 12 candies in total contain chocolate. So that's not a specific number. That's not a specific box, okay? We're told that 12 candies in total contain chocolate. So that means that if we added these two together, we would get 12. And we know that the total is 18. So the total is 18. So if I added these up and then added those up, I would get 18. And then same over here. All right. That's the information that I'm given. So now we just need to do a little bit of math to figure it out. So if I have 10 here, and when I add these two together, I need to get 12, then this must be 2, right? And they all together need to equal 18. So far I have 10, 12, 15 accounted for. So what's left? Well, 3, right? 15 plus 3 is 18. So that's kind of how that works. Sometimes you're given all the pieces, sometimes you're given some of these outside pieces, these sums, and you have to figure out what goes inside based on that. And this is just like the last one. Okay. So that is two-way frequency tables. In the next video, I'm talking about two-way relative frequency tables. So we'll look at that and how that's different. And I will see you in the next video. Let me know if you have any questions.